What people don't understand is AI is a technology, it's not a product. And even a chatbot is not a product. It's not been productized.
Welcome to Go, No Go. My name's John Brunner. This is a brand new podcast where we talk about technology, hardware, manufacturing, design, and the calls that can make or break great products. It's brought to you by Lumafield, where we spend all day looking inside amazing objects from every industry, from athletic equipment to medical devices and aerospace components. And in this podcast, we'll bring you a lot of the stories behind those products, talking to people who have delivered great products and asking them to reflect on how they designed them, how they manufactured them, and the impact that they've had on the world. In today's episode, we're going to start with an interview with Tony Fadell, the father of the iPod, the iPhone, and the Nest Learning Thermostat. After that, we'll talk through some recent news from manufacturing and supply chains, and then we'll close with a segment called Reconstructions, where we revisit an historical event that changed the world of hardware and manufacturing. Our very first guest here on Go, No Go is a legend in the product development space. Tony Fadell is the creator of the iPod, the iPhone, and the Nest Learning Thermostat, as well as an expert on product development from a variety of other experiences. Tony, it's an honor to have you on.
Oh, it's wonderful to be here and wonderful to be here again. So thanks for the invitation. Hopefully I have something interesting to say again this time.
We're all big fans of your book, Build an Unorthodox Guide to Making Things Worth Making, and we have copies of this on everyone's desk here. So one of the first things that jumps out when you read Build is that you write about how vision and detail are both essential. And normally these are kind of at opposite ends. You have, product people who are vision people and product people who are detail people. Looking across your experiences, at General Magic, at Apple, at Nest, at the companies you're advising now, what's the through line? How do you bring those together?
It's something that I've acquired over time, right? I used to be so much in the detail, really the engineering details of things, that sometimes you forget the big picture. And then from an engineering perspective, but you also forget the big picture from a customer perspective. You don't even know what that is. You're just like, I'm going to engineer this thing. It's going to be the best thing ever, and everybody's going to want it. And so, a lot of engineers start that way. Mm-hmm. And then they find out, wait a second, not everybody thinks like you, and not everybody, you have to really translate it and understand what the full audience may need to hear to be able to get them engaged and moving forward, right? And so what I like to do now is, through those very, very hard lessons, is make sure that you're balancing both at all times, and you're always talking about the why, and then what? Look at that. Isn't that cool? Isn't that cool? And that's what I love about Lumafield.
All of these great products are literally much more than the sum of their parts. I mean, it's all about the integration. And I think one of the breakthroughs in a lot of the products that we're going to talk about today have to do with the integration of software and hardware too. These used to be separate disciplines. And I think that a lot of the products that you've brought to life combine them in a very forward-looking way.
Oh, yeah, systems are absolutely important, and it's systems beyond the box, so to speak. It's systems that have all the network components into it and maybe multiple products all connecting either together peer-to-peer or from a central kind of server thing. So you really have to look at all of those pieces. And luckily with both the Lumafield technology as well as now AI to help you, you can start to really see how things are put, if you have open source, to see how things are put together.
Right. I want to take a little bit of a turn into manufacturing here. So the
Sure.
iPod and the iPhone were both big design leaps, and they were manufacturing leaps. Can you tell us a little bit about what you learned about factories and supply chains and the reality of knitting everything together at that scale?
It's so easy to replicate electrons, and it's gotten easier and easier and easier over time, right? But atoms are getting, well, in some ways it's easier than it was before, but because we have such design tolerances and such volumes, and we're really pushing the edge, it's getting harder and harder to scale those things up, because every nanometer can matter in some cases, right? And so you're always playing this game of how tightly can I get, how small can I get something? How much can I, how many can I make of that? And what's the yield of that? What's the price of that? And so you're always juggling all these parameters to try to make that work. And so in the earlier days, if you look at the original iPod, it had so much air in it.
Hmm.
Like, it's crazy. Like you're like, "Oh my god, we just threw that together." You never ship something like that today. It looks like, in some ways, a Kickstarter project.
Yeah, it has literal
Uh,
wires inside. You don't see those
eh,
inside
eh,
Apple products anymore.
exactly. It was just one board, dude. Like, it looked like a Kickstarter project back in 2001. Now that you look at it, and then you fast forward, then the iPhone, it's had a bunch of air, the original one, and now if you look at the iPhone Air, it's like, give me a break. There's nothing left. Like,
Hmm.
it's integrated to antennas on all four corners. Like, the battery is the structure is the it's crazy to
It's
think what
unified,
we've
totally
done
unified.
in 25 years to unify it all. And then and so that's something on the high volume side. And now you're making tens of millions of them, hundreds of millions of them. And to get that to work across, remember, you're not just talking about one design. We're talking about multiple battery vendors,
Hmm.
multiple mechanical vendors, multiple chip vendors, multiple display vendors, multiple PCB vendors and flex vendors. And when you think about it, the parameter, all the different permutations of all these things coming together with all their own design tolerances from all these different manufacturers and making them reliable again and again and again. So they all seem like they're the same, but if you really tear them apart and you look at all the various components from all over the planet to make that work at tens and hundreds of millions scale
Hmm.
is just incredibly impressive just on the manufacturing side versus what we were doing when you have extra air and you can
Right.
move things around. It's like, okay, you don't really need to worry too much about that stuff. It's a whole nother, these are layers of the cake of engineering to manufacturing, and they have to be so well integrated now. It used to be there was a gap between
Hmm.
engineering and manufacturing, and there's no way. It's all fully overlapped,
Yeah,
even all the way down to the chip packaging level,
that's
you
right.
know.
And that's Apple is at the pinnacle of being able to do that kind of integration and being in control of its supply chain that way. And I'm curious to have you think back to 2001 when Apple was a very, very different company. Market cap was under $4 billion. So rough order of magnitude, 1/1000th of what it is today. That was a
I
company
remember, and
with
no retail,
no retail
no
stores.
nothing,
Right. So
nothing but
how do you
Macs.
convince people? Right. Right. It's just, and they were a niche product. So, thinking back to kind of the uncertainty at Apple, it was struggling financially. How did that uncertainty affect your product development process? Was there stuff that you had to cut, stuff that you had to just be really
Well, it
ruthless in
was
order to ship it?
yeah, to get the original iPod out in 2001, it was literally, people didn't even want to do it. They wanted to kill the project before it even got started because they're like, we don't even have the cash for this. Not just the cash to design it, but to market it.
Right.
Like,
Right.
no one's paying attention to us. Why are we even bothering something that's not even in our wheelhouse? Well, and so there's executives at Apple today, and I'll leave them nameless, who didn't want that project who wanted to kill it.
Hmm. Hmm.
And I was like, and so we had to fight the internal issues and the external issues because Sony at the time was the Apple iPhone Air of the time of how they were doing. They owned everything. So we had to fight internally, we had to fight externally, and just execute as quickly as we possibly could because we didn't know if we were going to have money.
Hmm.
The whole company would be insolvent because it was literally 2 quarters away
Right.
from not having money, depending on whether it was a good Mac quarter or a bad Mac quarter. And it was highly in debt. And I had enough at that point. I had 10 years of disasters under my belt of
Yeah.
companies that went under, bad projects. And big political nightmares where they got canceled my projects. So I was like, we just got to keep our heads down and ship. And that
Right.
was it,
Right.
and I wouldn't say cut corners, but it was how fast can we de-risk and get this thing out the door? Like I said, with air and extra air and all these different things, like, let's show the world what it can be, even though it isn't what we would ever consider shipping in this day and age.
Right,
You know?
right. If you think back to launching, I'm a marketer. I'm curious about this. Did you have to market the iPod? In retrospect, we think of it as one of these like immediate successes, just like no question. Of course, the iPod, transformed the world of consumer electronics and how you experience computers and everything else. But when you released it, did you actually have to market it?
No, it needed to be marketed, but it didn't just need to be marketed. It needed to be fixed 3 times.
Huh.
And that's what I talk about in the book. Almost any new 1.0 product has to be revised 3 times before it's actually a success. And I've seen that over and over and over. Even ChatGPT has had to refine it till it got to be something to be useful. And even if it doesn't, it's not just hardware, it's hardware or software or both. And so we had to, it was only marketed to Mac users at the beginning. And, there was a big internal fight about should it be on the PC or not? Should the PC be involved in iTunes and the iPod and all those things? And it wasn't until the 3rd version did we get, yes, it needs to work on a PC. Yes, it needs to have a music store. That you just didn't rip your music off a CD. Where many of your audience probably don't even know what I'm talking about because it was so long ago.
When music wasn't just a
are
notional, purely digital, ephemeral thing on the internet.
Exactly. Now it's like whatever. You don't. It's just an app.
Yeah.
And so it took a lot of marketing, but it also took a lot of product revision and listening to the customer, because the first one didn't sell that well. The first one, Apple had less than 1% market share. I think we sold maybe 200,000 of the first one, maybe. And it just kind of first quarter, and it was all the Mac aficionados, and it went dead because
you saturated.
Nobody else had a Mac.
Yeah.
Right. And it was very expensive, and all those things. And the second one, we got the product better, but not great. And then we got the PC connectivity, iTunes Music Store, all of those things, and made the product with a click wheel, all that stuff. And everything come together, and then it just shot up. But we had to go 3 years to finally get it to go. It wasn't the first in the market.
Yeah.
It wasn't the first year or even the second year that it was going. And was combined with how much are we going to invest in marketing, right? So you're like, we're going to take the risk. Are we going to spend this much cash on marketing? Are we going to, and so you don't just blow it out the door with your first one. You're going to, you also have to figure out how to speak to the audience and which audience it is.
And so the initial audience was really the diehard Mac fans, and you saturated them pretty quickly because that wasn't a big group at the time. And then, do you remember what year the famous ads with like the silhouettes with the white earbuds came out?
Yeah, that was 2003, 2004.
Okay, so that was as it was going mainstream.
Yeah, it was as it was going mainstream, and then we started seeing the uptake, and then we started seeing, well, there was no real social media at the time, but there was this kind of popular media. That was on TV programs and things of that nature, and people started, you see them on news programs, and you started seeing them on TV shows and things of that nature, and popular culture, and then songs were starting to integrate it, right? And you started seeing with sports players and celebrities, and then it was like, oh, now it's something, right? And that then gave us the win to get to the iPhone.
I was a very early iPod customer myself. I had a second generation when I was in college, but I didn't have a Mac, and so I had to buy a FireWire card for my PC so that I could connect it, and then also use some piece of like freeware that's probably full of viruses to load music onto it from my PC. But I was dedicated, and it was a word of mouth thing, as you're describing. I mean, there really aren't that many things that you hear about through just word of mouth. But I remember my first friend showing up after Christmas break with an iPod, and it was just like getting passed around, and people are fascinated by it. It was viral marketing before such a thing moved online.
Yeah, absolutely. And then, what really was the next step above that was the marketing plus the iPod Mini, which was the first colored ones and then the colors match that, where the ads match the colors and all that stuff. And it was always small and it's tiny. It wasn't a bigger device. And it was like, oh, it's my cute little thing.
Makes it accessible to a lot more people.
Yeah. And it was also a lot cheaper too.
Right. So moving forward then, you worked on 18 generations of iPod. Is that right?
Yeah.
Wow.
18.
And then, and by the
feels like a whole other life.
Right. And by the time you finished up at Apple, I mean, it was much closer to the giant, well-resourced company that it is today. And then you left and you founded Nest, and you started building hardware again outside of Apple's, hardware infrastructure, product development infrastructure. What surprised you about scaling a new piece of hardware, with a decade of iPod experience inside Apple and going back to and doing it from scratch without the infrastructure?
The funny thing is, we didn't have as much infrastructure you might think at Apple as you might have thought. And that infrastructure was built for Macs. It wasn't built for small handheld kind of devices. So we had to build a lot of that. Like, we couldn't even get small capacitors and resistors on the board because we never at Apple had made those tiny kind of components before.
Really?
Or made products with those components or those types of screens. And all that stuff we had to kind of create. Now there was reliability labs and those kinds of things. Or that we were able to use. But at the end of the day, we had to create it and then recreate it at Nest. So we kind of knew what to do. And we also knew we had taught a bunch of the third-party contract manufacturers how to do it while at Apple. And we got to go work with them, like, some of those manufacturers again, and get to reuse it. So it wasn't as hard from an engineering perspective. It was hard because, we had to do it on a shoestring budget and all other stuff and make it feel and be as high quality as that kind of product. I think for me and a lot of the team was really the marketing, because almost all of us had come from the engineering, mechanical operations, and it was, okay, how are we going to do the marketing? And I had learned through osmosis a little bit of that, and that I had to really apply myself to that end of the thing and really think it through and build it in a way that you didn't, and this is what you didn't have, which was millions and millions and millions of dollars of marketing budget like you had at Apple.
Right.
That, and a brand that you could sit on top of, right? So that was the product was obviously challenging. I mean, don't get me wrong.
Yeah.
But that was like the new learning for me and a lot of part of the team is how to do Apple quality at a much lower scale from a marketing perspective, a branding perspective, all those things. And really, and the product had to earn, our brand didn't just sell it.
Right.
We had to make an incredible product that people then learned about our brand through.
Well, and good marketing begins with good product development and good product vision. Nest went into a neglected market. Like, no one thought that thermostats were sexy, that they were, worthy of the kind of technological and design, invention that you brought to it. Where did you see that opportunity? And then what kind of challenge did that present for your marketing when you actually delivered it?
Well, it was a wild idea that it was a pain point for me for many years, because I had a remote house in the mountains, and I wanted to control the heating and cooling. And I also didn't want to spend a lot of money wasting on heat or cooling when I wasn't there. And so it was like, okay, how do you make a product to do that? And so I was waiting for a product on the market, and I was also cobbling together kind of, maker style,
Right.
trying to put something together, and nothing was working. And that was over 10 years of trying and trying and trying. And I was just like, man, nobody's figured this out. And then, and the iPhone was just about ready to exist. So it was in the back of my head. I'm like, wait a second, I could do this. I know how to do this. Like, okay, we have to, there's a few components we didn't know how to do, but for the most part, it was a solvable thing. What I didn't know was AI, and we had put AI in the product. And so we had to get AI experts for AI at the time in 2010, 2011. And we were one of the first products that ever had AI in it, especially consumer products.
Mhm.
And that was, a million unit seller, many millions of unit seller. And so the pain point was this remote connectivity. And then it was like, and this kind of make it intelligent, make it so
Right.
it's not just you up or down from anywhere, but make sure that it can, sense when you're there and not, and really try to imbue all of these kinds of characteristics that we're now seeing in products back in 2010, 2011, trying to make them very smart. And smart's an overused word, but ours truly were. And then we did the same thing with smoke detectors and cameras and other things.
Right.
But we were just on the forefront of that. And it was all just pain points. It was pain points, as you said, of neglected products that cost money, needed to save lives, needed to protect, assets and things. And so we just went from, homeowners really need this stuff to let's make something better because no one had touched these things in 20, 30 years
Right.
using the latest technologies and connectivity that we knew about from the products that we had already previously designed and built.
If I'm imagining introducing a new piece of intelligent, home hardware in 2010, I can think of a lot of challenges related to like distribution, that the Home Depots and Lowe's of the world are not, they don't even, it doesn't even occur to them that they're on the lookout for the next great, technologically advanced thermostat to bring into the stores. Did you have to like go and completely learn the world of home goods distribution and, getting into hardware stores and stuff like that? Did anything surprise you?
Well, first we had to learn about thermostats in general and the world of HVAC, right?
Right,
And it
right,
was like,
right.
we're going to hire some experts out of the HVAC industry. Well, the experts were either dead
Uh-huh.
or
Uh-huh.
they were so encrusted in that world that they couldn't think any differently. So
Yeah.
we had to just go and figure it out ourselves by reverse engineering these systems and going out to all these homes and with multimeters and oscilloscopes and ammeters and going, okay, what are we doing? And trying
24
to make
volt
things
AC. Where else do you see that?
24-volt AC. I wish it was that simple. The amount of noise, those products are like a disaster from an electronic design perspective. They're
Yeah,
mechanical products that some mechanical guy hacked together some, electronics to sort of work. And so we had to go learn that. Then we had to learn the HVAC industry and installers, and then understand installers were not going to be around to market. And then going to not Home Depot, but going to Best Buy, who'd never done a thermostat in their life,
Right.
right? And then the Home Depot was like, what? Electronic what? They were like, we just sell these things like Home Depot.
Right.
Now, if you go into a Home Depot, if you go into a Best Buy, they have full home automation, like retail racks and all
Yeah.
these, try it before you buy it kind of things. And you're like, it had none of that. And it
Right.
reminds
Right.
me of when we were doing, PDAs in the late 90s when it was like, is this a calculator, a computer? Where does this thing go? Where does an iPod go? Does it go with the stereo equipment? Does it go with the computer? So we're always, if you're pushing retail to come up with a new category, you might be doing the right thing.
Yeah, it's a very conservative industry. They're just doing what's always worked, and that probably means there's opportunity for you as an entrepreneur.
Right, exactly.
So, you mentioned, putting AI in the Nest thermostat, and for listeners who haven't used one of these thermostats, I think what you're talking about is the fact that it learns from your day-to-day adjustments, bringing the temperature up around the time you're waking up and then turning it down maybe when you go to work, turning it back up in the evening and so on. And it recognizes those patterns and starts to make a schedule for you, right?
Correct. And we had to call it the learning thermostat because we couldn't call it the AI thermostat because people go, wow. Now, if you don't have AI in your name of your company or whatever, or your product, you're like, I don't want that. I want the latest and greatest. 15 years ago, it was like, that's scary.
Right.
I don't want that controlling my home. So we had to come up with new language, had to totally bury it, explain it in real simple details of how it works and, kind of whitewash it away. Like, yeah, don't worry how it works. It just works kind of a thing. And, it was quite a learning experience because I had never done AI at that point and I learned a lot. And what's very interesting is now with AI and knowing what I know that I'm like, Oh, how did you train it? What's the training data?
Yeah.
Because we had to go through all of those things. And how do you make sure it doesn't do something weird like hallucinations like today? And so it's very interesting that those same rules still apply and will continue to apply regardless of whether it's an LLM or an LAM, whatever the AI is, it's really about your
Yeah.
training data sets and everything.
Well, so tell us a little bit about that, because as an investor now, you see a lot of hardware startups. You must be seeing a lot of AI in hardware startups. So tell us about the challenges you faced bringing AI into the Nest thermostat, and do you see everyone making the same mistakes or trying the same things today at a fundamental level?
Yeah, I think for us was, you know, we were just like, could we even make it work? Like
Hmm.
now you're like, sure, of course it'll work. You can just simulate it and da da da. Like
Yeah, yeah.
back then we're like, can we get enough data? Here's the one thing that is very similar today that was very similar today as it was back then, which is when you put AI in a product, how quickly does it learn you and your habits to be able to work and give you benefits right away? And so when you have small products with small memory, and then we're not talking about connected to the net with these large LLMs with, gigawatts of processing. We're
Right.
talking this had to work on a battery operated thing in 2010 with just the processing it had and the memory it just had, and it still had to be cheap, right? And so when you think about that, we're still everybody today is still going, okay, what's my cost per token and how quickly can I get down? How can I get my power down? How can we get all of these things down so that it can serve a lot of people, whether it's on your device like Apple's trying to do or Samsung or in the cloud. Everybody's still trying to compact that. And it's when we started with something that was so constrained, we had to make it work in that in highly constrained environment. And there were other techniques even back then that we couldn't use because they were too powerful or consumed too much energy or too much memory that we couldn't even use. So we had to figure out one, AI, and two is can we even make it work in this
Hmm.
incredibly constrained environment, which is way more constrained than we even have on the smallest devices today in the market. You know?
Right, right. What are you seeing, among the hardware startups that are trying to bring this to life, and the bigger companies? Like, what mistakes do you think they're making in trying to bring AI into the physical world through hardware?
I think it's here are lots of capabilities and here are a lot of things, and you can start with the chatbots first.
Hmm.
You don't know what they're good at and what they're not good at. You have to take a swing at it and go, "Oh, I think it works," and then you give it one math problem and it solves a math Olympiad question, and then you give it a simple thing like count the number of R's in the word, and they're like, can't even do that,
Right, right.
right? So you're like, it's so imbalanced and so jagged, and you don't know what it's good at and what's not, and whether it's really big, like in a server, or it's down to small products. What 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 people don't understand is AI is a technology, it's not a product. And
Hmm.
even a chatbot is not a product. It's not been productized. So if you want to try to use that chatbot in a medical application, in a finance application, in a some kind of critical thing, systems control, like let's say thermostat control
Hmm.
or energy control, you got to really understand what it's trained on. You have to understand all of the permutations of that to guarantee it will work in these critical situations. Otherwise, you can't rely on it, and you're going to always need the human there, right, to check everything, which is fine. But you can't sell it like, oh, it's this answer engine, but yet you don't know if it's answering it properly. And if it's in critical stuff, now the bar is raised that much higher. And it doesn't matter, like I said, if it's a huge system or if it's a tiny system, it's got to work in these critical situations. And too many times people are like, it does everything, but it really doesn't do any one thing so well that you can rely on it. Like we have agents, but you're like, well, the agent didn't work for me this day and it worked yesterday and it sometimes didn't. You'd fire anybody who did that
Right,
if they
right.
were on your team. You got to rely on them. And so I think we're still in a very, very early stage where and I don't care how impressive the results are of Claude or OpenAI or whatever it is. um, if it still has this jagged thing and you can't rely on it, then
Hmm.
it tells me it hasn't been productized. So you really know what you can rely on it for.
It's interesting. That's a great way of putting it. One of the things that I really think is brilliant about OpenAI's marketing around ChatGPT is that they've typically shown it being used in lower stakes settings.
Yeah,
Famously,
yeah.
sort of Studio Ghiblifying your images, or asking about a restaurant reservation, or kind of like lightweight things like that. They're not showing it controlling a power plant, or
Yeah, but then they'll say it wins the math Olympiad, and then it does this, and it
yeah,
does,
yeah, yeah.
and so again, it's like, see how impressive it is. But then when you go to use it, it's kind of a letdown. Like, still try to get a photo out of it that photorealistic thing, and you give it all these prompts, and it still breaks. So
Right.
we're still at the very, very earliest days, and frankly, I think there's a lot of technology that still needs to be produced. It's not just scaling that's going to make AI work. It's going to be a lot of better training data and also models, not just LLM models, but other things, neurosemantic models, reinforcement models, other things to really make it so that you can rely on it. And it has to be scoped down. Because once it's scoped down and it's understood, then you can also price it right so it can be attractive for people to use it. Right now, you got billions, almost trillions of dollars going into this, and everybody's forward pricing everything, but no one's making any money because it's just not in the right. It doesn't have the right parameters yet to everybody likes it in some form. But when you say you're going to rely on it, and it's going to cost you $2,000 a month to use because it really works, people will be like, "Well, wait a second, I
Yeah.
don't know if I want that."
Yeah, and I think people forget in the physical world, or with hardware products, with things that act on physical things. Specialization is the way to success, and eventually you can become a little bit more generalist. But you could argue that the smartphone is the epitome of general purpose hardware. It can do all of this stuff. It's always in your pocket. It's connected to the internet. But it's easy to forget how long it took to get there, right? The first iPhone was just a handful of functions, no app store. It took years before the iPhone was something that could like replace your laptop on a short airplane trip, or or was something
Sure.
that you wouldn't just like put down and move to your computer to write a reply to an email.
Exactly. And it's still, in some ways, even an iPad today,
Hmm.
tablet is still that. People are like, well, when do I use my tablet? When do my computer? And they're like, okay, I'll just default to the computer.
Right.
So we're still trying to get there. And, people are like, look at the adoption curves of AI versus everything else. You know what? It's riding on the shoulders of giants. I remember when we didn't have the internet, and then we didn't have, broadband, then we didn't have Wi-Fi, and then we didn't have mobile, and we didn't have social, and then we didn't have, incredible processing and central servers. And so when you finally built out this entire network and everything end to end is like starting to really work, and then you go, oh, AI shows up, and then it goes everywhere, and everyone's using it. Well, sure, duh. When you made it frictionless because you've set up the whole planet to allow it to happen, of course it's going to go that way. It doesn't mean everyone's going to pay for it in the long run. It doesn't mean, because you still have to show incredible value, because they're going to have to price it at what it really costs to deliver. And they're not really doing that. Like, they're giving it to governments for 49 cents and what have
Right.
you. And so there's still reckoning, and there's still a lot of stuff going on, like you said. Just because the infrastructure was there to allow it to flow everywhere doesn't mean it's amazing for lots of people. It can do lots of amazing things, but for who, for whom, and how often, and can you rely on it?
Right. So in that stack of technologies that were the enablers that you just listed, that have made the modern world what it is. What do you think is the next one? Is there something you see that's emerging now where you're like, that's going to be at the foundation of the next generation of great products?
I think we are at the point where, you hear of the super apps, and there's like everything under the sun in the super app, or you go to your neobank, like a Revolut or the Robin Hood or something
Hmm.
like that, and they have tons and tons of features in it. And these apps, and they're like the Adobe apps or Canva or Figma, and you're using them mobile or whatever.
Hmm.
I see, and there's just a plethora of palettes of tools and everything else. I see that inverting.
Hmm.
I see these palettes of tools going away, and you're going to have a agent that who understands the software really well and say, what was it you want to try to accomplish today? And then start to surface things, and you're going to start to see these interfaces be much more dynamic than a static thing. You look at your Outlook or your mail app, and it's always the same things. And
Yeah.
60% of screen real estate is all tool palettes and stuff. And you're like, I got a content window like this. It's going to learn over time, just like the Nest Learning Thermostat did, is like, you don't use any of that stuff. It's going to go away, and it's going to surface it when you need it, or you can ask it, hey, I'd like to do this. How do I do it? So that so these tools will get smarter to work with you. And it's not just this barrage of tabs and
Yeah.
buttons and things of that nature. I think that is a logical next step that so many apps that are already highly used tools by many professionals are going to get simpler, so that more people can adopt them and get superpowers. I think that's one. It's not going to just be like, hey, you go off and make me, AI, go make me all of these things, and then I'm going to just use it like that. You're going to want some kind of, sure, some starter thing that the AI can do, but then you're going to want to have the tool palette and everything to work with in concert with it to really bring to life what is in your imagination, because prompting is not enough. Just
Right.
texting. It's like the old command line days, that's only going to get you so far.
Yeah, it's one of my favorite UIs is Photoshop, because it kind of displays very clearly the the evolution of the software over like 30 or 40 years, right? And you have these menus that are hundreds of options once you really drill into them, and it's like save as parentheses new, save as parentheses legacy, save as parentheses something else, and it's like everyone has built their workflows on this since the mid 1980s, and the software still supports all of those workflows, but is forbidding to anyone who wants to use the software to be creative and has never done it before. The learning curve is so steep. So what you're describing would make really powerful tools like that accessible to a much wider variety of people.
Exactly. And just so you know, Photoshop wasn't until 91. I know because Photoshop was built. Tom Knoll built it in the lab that I worked at at University of Michigan, and I had the little thing. It used to be a photo booth. It was called Photoshop. So it's not. But and I hope that LumaField is also going to be doing something like that, because you're going to have such incredible power in these scans and everything, that your interface is going to be able to be much more morphing like that, to give people like, oh, I want to do this kind of analysis and this kind of thing, whether it's in real-time flow on a manufacturing line, or if it's in one-time testing, destructive testing, these kinds of things. So I'm looking forward to seeing how the innovative team at LumaField starts to adopt these things, not just at the analysis level, but at the tool level, to give people superpowers.
Yeah, that's part of our vision. I mean, we've implemented an agent called Atlas that's inside our analysis software, Voyager. It lets you, talk to the agent and talk about the analysis you want to run and automate things. We've seen some great uptake on it.
That's great. Well, I'm looking forward to the next versions. You guys are smart, so it's going to be wild to see what the mere mortal will be able to do with it.
All right, and with that, I'll wrap up by asking you the question that we ask everyone who comes on this podcast. Can you tell us about a go, no-go moment that you've encountered in your work? How did you face it?
A go, no-go moment.
It's the title of our podcast.
Well, I think it is the title of the podcast. I think it was really about whether or not I should do Nest. I had already done so many things. I was like, do I really want to take on this challenge? And I put a little bit about this in the book, which was, do I really want to spend the next, 10 years of my life building this thing? Because I know how hard these things are to build from scratch. And I was like, and I had already over 20 years in the business. And I'm like, oh, I know how painful this is going to be. I wasn't just like a 20-something going, it's all going to be easy. So I had the scars. And what was really interesting was when I would talk about the problem, the solution, that with whoever it was I was talking with, who's, understood it well enough, they would just go, how can I help? And so the path kind of, while it was very cloudy and dark in a way, because I had so much previous experience, it opened up and the light shone when like, oh, I'll give you money for that. Oh, I want to join your team. Oh, we'll help you with the chips. Oh, can do this. Oh, and it was just like, ooh, and it was just
Wow.
like, oh, it's go. Because it was like, I was like, no, I'm not going to be a glutton for punishment again. No, and then it was like, oh, I have to do it.
Yeah, the ecosystem called you back in.
They pulled me back in.
Yeah, I love it. Well, Tony, it's been such a pleasure to talk with you. You've always been a great supporter, and we really appreciate your coming on the show today. And I encourage all of our listeners to read Build, Tony's incredible book about great product development and great companies.
Oh, hey, thanks, John. Thanks a lot. And looking forward to seeing this episode and future episodes.
All right. Thanks so much, Tony.
Thank you.
Welcome back. I'm John Brunner.
And I'm Alex Howe.
For our next segment here on Go No Go, we're going to talk about some of the news headlines that we've been reading about manufacturing and product development and technology in general. Alex, what do you have for us?
The first story I wanted to touch on was an article by the New York Times about how Trump's tariffs are damaging our largest source of screws. And so I think most Americans are familiar that a lot of computer chips come out of Taiwan, but Taiwan has actually been the #1 source of screws and metal fasteners to the US for the past 30 years.
These are objects that you don't think about in terms of the supply chain. They just are.
Exactly. That's something you really take for granted because they're so essential, right? And so far down in that supply chain. But with the 50% tariffs on steel and aluminum, now these Taiwanese producers are facing a lot of pressure. You know, their margins have already been pretty thin. They're seeing competition from China. And so while the bigger companies are able to move to other countries within APAC, a lot of the smaller ones, unfortunately, are having to close.
And how's this affecting American manufacturers?
I think it'll be interesting to see how this plays out and its impact for American manufacturing. Something the article points out is that, you know, TSMC even is having issues hiring like high wage laborers for their fab in Arizona. So you can't really imagine that a lot of Americans are going to want to work in like a screw factory.
Yeah. This whole thing is a really interesting illustration of how disruptive tariffs can be. You know, if you think about where U.S. manufacturing is really competitive, it's in very high value, complex products like airplanes and surgical robots. And things like airplanes and surgical robots have a lot of screws in them. So if you just sort of apply blanket tariffs to a lot of the upstream inputs in these products that American manufacturers make, it can be quite disruptive. The same is true of applying tariffs to base metals like steel and aluminum. You know, we would all kind of find it thrilling if there were cities in the U.S. that could go back to looking like Pittsburgh in 1955 with like smokestacks and huge steel mills and so on. But it is advantageous to the U.S. automotive industry, among others, to have access to inexpensive metals. And that is what, you know, helps them thrive as assembly operations and integration operations in the U.S. So this is one of many kind of inputs to American manufacturing that's getting reordered under the tariff program.
Yeah, all of those costs really stack up. And I think what you say too about like higher value manufacturing really being more attractive is even true in Taiwan. A lot of these screw manufacturers talk about how they have to compete with the computer chip industry for government support and for labor, because of course people maybe prefer to be in the area that's more lucrative and more flashy. And so it's a real challenge even there.
It's something you hear factory managers here talk about a lot. It's also really hard to hire employees at manufacturing operations at factories in the U.S. for exactly that reason. You can make pretty good money working in an Amazon warehouse or in a coffee shop, and you know there's a generational difference in the appeal of factory work. A lot of younger people have grown up with their parents saying like, "I hope you don't have to work in a factory." But those can be really good jobs and can be quite lucrative if you have the right skill set for it. Speaking of tariffs, you found something interesting about Lululemon and how they're distributing their products and how this is also being disrupted.
Something I was really fascinated by in Lululemon's latest earnings report, and they also covered this in Supply Chain Dive, is that the de minimis exemption and the end of that has really materially impacted their business. So apparently, about 2/3 of Lululemon's e-commerce orders in the U.S. are shipped through Canada using the de minimis exemption.
Interesting. You think about the de minimis exemption being used mostly by companies that are shipping straight from China to consumers. But it seems like Lululemon found a different way of organizing its distribution.
Exactly. They had 7 distribution centers, 4 of which were in Canada. And so they could ship these individual consumer orders across the border using that under $800 exception and save a lot of money on taxes. So now that they're having to pay those taxes while they figure out how to reallocate their distribution centers, it's going to have a real negative impact on their margins.
And of course, Lululemon is headquartered in Canada, but there's something else at work here that's interesting. You know, if you ship individual packages from your countries of origin to consumers in the U.S., that's a pretty expensive way to do it because you're shipping individual like parcel freight. The alternative is to take a giant shipping container full of merchandise and send it to a distribution center where it's broken apart and sent on to customers there. But then you can't get a shipping container through the de minimis exemption. You wind up paying tariffs on the contents of that. So it seems like what they've been doing is shipping in bulk from their factories overseas into Canada and breaking apart the shipments there into individual consumer shipments and then sending them across the border into the U.S. under the de minimis exemption, which is kind of a brilliant, cross-border strategy.
Yeah. Hopefully these losses will be offset by the new Amex Platinum promotion for Lululemon. I've never seen Lululemon stores so crowded as I have in the past week
Interesting. Well, some tariffs actually disrupt things and others don't, I guess. So the de minimis exemption was available for very inexpensive shipments. We also have some tariff news from the other end of the value chain related to shipping.
Yes. So now if you are shipping into U.S. ports starting October 14th, if your ship is built in China, you will have to pay some additional fees. And the average estimated fee for a Chinese ship will be over $680,000. This can be remitted to you if you purchase a U.S. built ship in the next 3 years.
This is interesting. It resembles a similar fee that the Trump administration has promised on pharmaceutical manufacturers, that there are big barriers to importing drugs unless the drug maker is actively developing a factory in the U.S. Obviously, a lot of loopholes involved here because you can sort of always be in the process of developing a factory, or you can, always be in the process of negotiating to buy an American-made ship. But are there enough American-made ships for everyone to even go out and purchase?
Yeah, not really. So China built 70% of ships last year, followed by South Korea, and then Japan's at about 7%. The U.S. makes about 0.2% of the world's ships. And in an article from the Financial Times, it was looking at Japanese shipbuilders because they're having a lot of increased interest in their ships, but they're sold out for years. So you can't even get a Japanese ship if you wanted to kind of get on that wait list. And so it makes it even less realistic that you can hope to get an American ship because the kinds of facilities you need in order to scale that kind of manufacturing endeavor are really enormous.
There's a great installment of Construction Physics that talks about why it's so hard to build ships in the U.S. And we'll link to that in the show notes for this podcast, along with links to everything else that we're talking about in this segment. But basically, there have been efforts for decades to kind of prop up the U.S. shipbuilding industry, beginning in the early 20th century with the Jones Act around 1920, that requires that any freight that's moved between U.S. ports by ship be carried on a ship that was built in the U.S. and is owned by U.S. citizens and crewed by U.S. citizens as well. So it makes it very difficult to transport things by ship in the domestic, transportation market. And because that side of the industry has been sort of inhibited, that's also led to, decrease in demand for American ships. And at the same time, American shipbuilding just wasn't able to keep up in terms of labor productivity with first Japan and now Korea and China in terms of the advances in processes and so on that they have been able to implement there. So it's a really interesting field.
Yeah, I'll be curious to see how that develops with this initiative.
One other initiative related to shipping, AI detection of dangerous cargo on ships.
Yeah, so the World Shipping Council, which accounts for about 70% of global freight capacity, is starting an AI initiative. And what this AI tool is going to do is go through the manifests and basically detect patterns of anomalies that may indicate misrepresented hazardous materials. So there's a real problem in shipping right now where, in order to avoid additional costs, some manufacturers are misrepresenting the contents of their containers. So they might be labeling something as electronic goods when it's actually like lithium ion batteries.
Mm-hmm.
And when that's misrepresented, what can happen is the cargo might be placed in an unsafe area, like in the hold, and then it's leading to an increase in fires. There have been some really high profile fires lately, like the ship that sank off of the coast of Alaska that had a bunch of cars in it, including several EVs. And so this is like a real problem for the industry.
So this is an entirely data-based approach, right? They're not scanning anything. They're not inspecting the shipments directly. They're just looking for patterns in the manifests, right?
Exactly. So they can see like if a certain description, like toys, has been used, and they can combine it with the geographic data to kind of determine trends, and they can evolve over time as these misrepresented shipments are caught. And that can then be used to suggest physical inspections to verify the goods. Yeah, so this is an entirely software-based tool. So we'll look at what's written on the manifest, and it can also learn over time. So let's say a descriptor, say like toys, has been used to misrepresent something coming out of a particular country. It will then flag that in the future, combining the term and the location. And this can be used to raise the need for physical inspection of the containers.
Those are some of the headlines that we've been reading around manufacturing, technology, product development, supply chains in the last week or so. If you have anything you think that we should discuss on this podcast, just send us an email at gng@lumafield.com, just like Go No Go, gng@lumafield.com. Moving on, I'd like to talk about a report that's been getting a lot of circulation in the last couple of weeks, and it's authored by our very own Alex Howe, the Lumafield Battery Quality Report, which is available as a free download. We'll link to it in the show notes. But it reached an important conclusion about the quality of batteries that are widely available online. Alex, tell us what you found.
So for the Lumafield Battery Quality Report, what I wanted to do was look at a type of battery at scale to see, like, could we find anything interesting about like different suppliers in the battery supply chain? So I narrowed in on 18650 battery cells, and these are cylindrical cells. They're super common. The average consumer isn't replacing 18650s in their devices, but many common household products that are rechargeable have packs made of several. So for example, our cordless drill in the office that has 5 18650s in it, or our colleague's e-bike battery that has 39 18650s in it.
That's a lot of batteries that could go wrong.
Exactly. And so 5 billion of these batteries are produced every year.
Oh my God.
It's crazy. It's actually seems to be about like half of like all batteries made are like 18650s, more or less. So what I did for our experiment is I bought 1,000 of these batteries, which is, really small compared to 5 billion, but it's a good amount of batteries to have in an office here. And I sourced them from different places. So I bought 100 each from 10 different brands. 3 of those brands were OEM. So those are like the well-known, like high-end, like original battery manufacturers. I bought 3 brands that are rewraps. And this is an interesting category where they're buying batteries and basically rewrapping them, right? Packaging them as a different brand and selling them. And normally those should be purchased from OEMs, but because they're rewrapped, we can talk about is like you don't really know what's actually inside. And then I bought 4 different brands that were low cost and counterfeit. So these were from like Temu, Amazon, like really easy to buy off of e-commerce platforms. And I think intuitively, right, you assume that the cheap batteries are going to be worse.
Yeah. And are they?
Yeah, they are worse, but they are like so much worse that I was always surprised by the degree of delta. Like for some of the quality metrics we measured, they were 7 times worse.
Wow. That's why is that dangerous?
Yeah. Well, so I looked at 2 particular types of battery defect. It's called like anode cathode overhang is the main one. And basically you have these negative and positive layers like wound in the battery. And you want to have that negative layer sticking out about 0.5 millimeter above the positive. Because otherwise, as you're using the battery, lithium particles are floating and they can form dendrites. And depending on where these dendrites form, they can degrade your performance, and they can even pierce the separator and lead to internal shorts. And internal shorts are what's causing these overheating, these thermal runaway events. And so the industry average for that's about 0.5 millimeter, but 33 of my low-end batteries had negative anode overhang, where actually the cathode, the positive, is hanging over the negative, which substantially increases the risk of that type of really negative formation happening as that battery is used.
That's a substantial defect, right? I mean, you'd expect to see it in basically zero of the name brand OEM batteries, the Panasonics and Samsungs and Murata batteries, right?
Exactly. And so we didn't see them in any of the OEMs or in the rewraps either.
And in the low cost or counterfeit category of batteries, it was like 1 in 13 had that effectively.
Yeah, so that's about 8%. So that's a lot, right? So when you think about the risks in batteries, I think the common statistics, like, okay, 1 in a million batteries may experience like a reliability failure, right? And that's where it's like, oh, it's not holding the charge, it's not performing as expected. And maybe about 1 in 40 million should be the risk level for like a catastrophic event like a fire or thermal runaway. But when you look at these batteries and how much worse they are, you realize like that risk is not evenly distributed between manufacturers and between cells.
And what did you find in the rewrap category? So where are those batteries coming from in theory?
Yeah, so rewrap batteries, they should be purchased from the OEM and then, rewrapped and sold under a new brand. But sometimes like some gray market stuff can happen. So you can have rewrap batteries where they're OEM batteries, but they're ones that maybe failed QA, right? And so they're technically scrap. Or they could be batteries that were assembled into packs and then those packs were scrapped. So then they're disassembled and those batteries are salvaged. So there's like a little bit of a risk factor because they might be OEM, but not like at the OEM standard, or they might be used, or who knows.
And so 2 of the rewrap brands that you looked at looked pretty good, right?
Yeah, like I would say all 3 brands looked okay. I wouldn't hazard against any of the brands, but you did see that like 2 of the brands, eFest and VapeCell, I think it's VapeCell.
Vapcell, maybe.
They had like really tight distributions. They were a bit wider than the OEMs in some areas and like on par in others. And then the third rewrap brand I looked at, Trustfire, again, it's like nothing like the low cost batteries, but it was definitely like a shifted distribution and a bit wider than the other 2. And I think that speaks to the fact that like with a rewrap, you're just not 100% sure like what's really in there.
You wouldn't, so to speak, trust them to not catch on fire.
I think they're targeting flashlight users. So that's where it's like a
trust
reliable torch flame in the terms of like a flashlight. Like
I see. But yeah, the seems like the takeaway is that a category of battery whose whole purpose is that you don't know what's actually inside it turns out to be perhaps a little bit risky.
Yeah, it's a little bit of like a blind box, like a little less fun of a blind box than like a Labubu.
Or Pokemon cards or something like that.
Exactly. And that's where CT is really useful, right? Because you buy these batteries, and I think a big question we've got is like, what can I as a consumer do to validate the battery? And the only thing you really have at your disposal is like capacity testing and trying to buy from brands that are well reviewed, from sources that are well reviewed. But with CT, we're able to look inside the battery and see these quality structures because you can't cut open a battery. It's very unsafe
Don't try.
to take a look.
But I mean, a lot of these batteries would have passed a cursory quality check at a factory, right? Because they can be charged and they can hold a charge. But without that X-ray CT scan, you have no idea what the real quality characteristics are inside the battery that might turn into a problem after, 10 or 100 cycles.
Exactly. Like these defects will lead to problems as the battery is used. So these preliminary capacity tests don't give you a good indication as to like the actual quality of manufacturing.
So any advice on the basis of this for manufacturers and consumers around, finding high quality batteries and avoiding the problematic ones? Yeah,
I think the big thing for manufacturers is it's important to validate your supply, like doing some spot checking, especially I think so many companies are dependent on distributors. And being able to have some tools to take a look inside and double check that nothing is slipping in there that shouldn't be slipping in there is a good way to protect yourself. Because ultimately, if your device catches on fire because of the battery, it might be the battery manufacturer's fault, but your brand name is the one that the consumer is going to associate with that technical problem.
And to bring this back to the kinds of things we were talking about a few minutes ago, with trade barriers changing, on a very regular basis. There's a lot of new kind of variability in the global supply chain for pretty much everything, and batteries included. A lot of batteries are made in China or South Korea or Japan. And when you apply tariffs selectively to different countries, you kind of create an incentive to mislabel products, right? To make them look like they're coming from different countries of origin or from different manufacturers. So it's introducing perhaps another layer of risk for the electronics companies that are looking to integrate batteries and want to make sure that they're getting the highest quality batteries.
Yeah, that's a good question. And that really relates to another common question I've gotten about this report, which is like, how pervasive is this problem? Like, how prevalent are these like really bad, like low quality batteries? And, the unfortunate answer is I don't think anyone really knows, because technologies like CT have generally been quite expensive and inaccessible, and there aren't really standards for battery quality. There's a lot of standards around battery shipping to make sure that they don't catch fire on the plane or on the boat or things like that. And there's regulations around like child safety to make sure like batteries, like coin cells, are well embedded in devices so they can't be extracted. But there's nothing around like quality per se. So there's not really any tracking. And given this kind of shadiness of things going on, I don't know that anyone can say to what degree these batteries have infiltrated the supply chain. But it was really easy for us to find a lot of bad batteries.
Yeah, it was fascinating that you could just order these online, and then the CT scans that you ran took less than a second a piece, right? And with newer inline production scale CT scanners like the Triton from Lumafield, you can scan a battery in less than 5 seconds, even accounting for the time that it takes to move the part through the scanner. So thankfully, there are ways to detect these kinds of problem batteries now at the point of receipt, instead of just sort of hoping that your supply chain is being honest with you.
Yeah, and I think electronics, right? We're only getting more and more of them, and the demand for lithium-ion batteries is only growing. So it's important to evolve these inspection technologies alongside with that.
Yeah, and the volumes of energy stored in lithium-ion batteries, when you consider the move toward electric vehicles, the move toward grid-scale renewable energy storage, plus just the proliferation of consumer electronics. Well, you can download the Lumafield Battery Quality Report at lumafield.com. We'll include a link to that in the show notes attached to this podcast episode, but it's a great read. Thanks, Alex.
Yeah, thank you.
Moving on to our last segment of the podcast, Reconstructions. This is a segment where we look back at pivotal events that changed the course of manufacturing and product development. Today, we're going to talk about the Samsung Galaxy Note 7. Did you own one of these, Alex?
I did not. My college roommate had the preceding model and the one that came a few generations after. But I remember this was a very iconic phone that everybody knew about, right? Your flight attendants made sure you knew exactly what that model was and how important it was to not own it.
This phone got a lot more airplay, let's say, than most phones. It was a very popular phone. It sold upwards of 2.5 million units globally. Samsung doesn't make this line of products anymore, but it was basically the Galaxy, but with a stylus attached to it. And shortly after it was released, in the summer of 2016, reports started to come in about the phone overheating, especially when it was being charged. And Samsung kind of issued some statements around, holding back some inventory, doing some final quality checks. But then some fires, some pretty serious thermal runaway events, let's say, started to happen, and it began to attract the attention of regulators.
So do we know now what was causing those battery fires specifically? Like, was it an issue with a single source?
So it turned out that there were two different battery design and manufacturing flaws at play. The handset initially shipped with a battery made by Samsung SDI, which is a company that's kind of a sister company to Samsung. Common ownership along some dimensions, but a separate company. It was determined in some postmortems that the issue there was a tight clearance on one of the corners of the battery. So this was a prismatic cell with a hard case on it, had a very sharp inner corner that deformed some of the overhanging anodes in the battery and kind of smushed them over and led to shorting. Samsung did an initial recall of some of the first handsets and revised the phone to have a battery from ATL, Amperix Technology Limited. And that battery turned out to have a manufacturing defect. It had burrs left on the tab welding in the battery. And when the battery expands and contracts very slightly as it heats up and cools down during the charging cycle, the burrs rub against the film layers inside the battery and can lead to shorts. So two completely different battery suppliers, two completely different sets of design and manufacturing flaws.
That's incredibly unlucky.
I know, it really is. Amperex is an interesting company, by the way. It's owned by TDK now, but it is kind of the original parent of CATL, the world's largest battery manufacturer, which stands for Contemporary Amperex Technology Limited. Kind of a funny name in that it makes you question Amperex. It's like, is it not contemporary?
CATL is really fascinating because it started out right as their EV spinoff, but now they do batteries for absolutely everything.
Yeah, and just like an enormous player in the market, huge market share. So the Note 7 recall was actually pretty fast, as these things go. It was introduced in mid-August 2016 and was basically completely withdrawn from the market by the middle of October. Samsung had kind of given up on the product line and taken it off the market completely. In the meantime, it got the attention of a lot of aviation regulators. So the FAA banned it on all U.S. flights. And as you mentioned earlier, it got a lot of airtime. There was a time when if you were flying in kind of like late 2016, early 2017, every flight attendant announcement at the beginning of every single flight said, and if you have a Samsung Galaxy Note 7, you need to like ring the bell now and you'll be taken off the plane. You know, every airline homepage had a giant banner across the top that said Galaxy 7 Note. And when you checked in for flights, you had to like attest that you didn't have a Galaxy Note 7.
It must have been really bad for sales. I mean, to buy a mobile phone that you can't take with you is not a great value proposition.
Yeah, stationary phone. They should have just marketed it differently. The overall cost was estimated at something like $17 billion for Samsung, according to one analyst, in terms of the direct cost of the recall, as well as the hit to their sales that came about from kind of the loss of consumer confidence.
I'm curious, like, did you have a Samsung Galaxy Note 7 or did it impact your relationship with your mobile phone at the time?
You know, I actually was an Android user at the time, but I did not have a Note 7. I was just struck by how often I was hearing about the Note 7. It kind of gave it an interesting cachet. I was always curious to see one, but I never saw one. How about you?
No, I didn't. I was just iPhone user from the beginning.
So the Note 7 was a phablet, which is always an entertaining category of phone. Have you ever had a phablet?
I love phablets. Like, a big fan of like the plus size phones. Like I'm really holding out for like the folding iPhone. Like that can't come soon enough for me.
Have you considered buying one of the Huawei folding phones?
I like the tri-fold Huawei phone. I really wanted the Pixel Fold. So I asked my husband, because, you know, when you have like your household, right, what operating system you're on, it's a big question. So I was like, hey, like, can I buy the Pixel Fold? And he's like, I guess I'll just never text you again. So I'll just have to wait for next year.
There's a great essay by Paul Ford, one of the early bloggers, from about 10 years ago. And we'll include a link to this in the show notes as well, where he talks about how the blue messages in iMessage represent the apex of product management, the purest example of product management, because the blue messages serve no engineering purpose. Like an engineer working on their own to create like a high quality, secure messaging experience would never think to kind of build a little bit of class warfare into the messaging platform. But Apple just made this very, very subtle move early on in creating iMessage and the iMessage service that conveyed, you know, whether the person you're talking to has an iPhone or a different, you know, phone operating system. And it's very, very deeply embedded in our lives, to your example.
Yeah. Did you ever have a phablet?
No, I've never had a phablet. I used to carry around my iPad to a lot of places. I used to like read the news on it on the subway. I used to like have it every time I got on a plane. And because the phones have become so much more capable, I'm just not really drawn to my iPad anymore. So I leave it at home. I read sheet music off of it on the piano. I have the biggest iPad, the Pro, 12-inch iPad, and it's great.
Awesome.
And with that, we're going to wrap up. This has been episode 1 of Go No Go. We hope you enjoyed it. If you did, Please subscribe. We're on all of the podcasting platforms. And if you don't mind, rate us 5 stars wherever you listen to it. It really helps get the word out. If you want to reach us, write to gng@lumafield.com. That's just like Go No Go, gng@lumafield.com. Tell us if you've come across something interesting in the news, or if you think there's someone we should talk to on the show, or something that we should put in a Lumafield CT scanner. And if you want to see a Lumafield CT scanner, by the way, you can do that in San Francisco or Boston. And we are also bringing a lot of CT scanners to trade shows this fall. So check out the upcoming events list on lumafield.com if you're interested in seeing a CT scanner for yourself. We'll look forward to seeing you next time. I'm John Brunner.
And I'm Alex Howe.
Go No Go is brought to you by Lumafield, which was founded to upgrade manufacturing. You can learn more at lumafield.com. Go No Go is produced by Austin Carter and edited by Brian Tran, with additional assistance from Eric Petralia.